Hello, today we're going to talk about variables, one of the building blocks in Java and any programming language. Variables are values that you expect to change during the execution of a program. They don't always change, but they are there to allow us to have values that do change during the operation, during the execution of the program. Variables are declared, that is, we establish the intent to have a variable. When we declare them, our system puts aside some storage space. That storage space is in bytes, and that storage space is associated with a name, the name that we give to our variable. The assignment operator, the equal sign, is used to put a value into that named space. The declaration is made through the declaration of the variable type and then the variable name. With that variable type, we put aside storage space to hold a variable of that type. A variable name is indeed an alias for the storage space. The declaration of a variable can be made in this way. Int a, that declares that we will have a variable of type int that will be named a. Or double b, that declares that we will have a variable of type double that will be named b. In each of these cases, you see the semicolon at the end of the line. This is an executable line of code. You'll also note that these lines of code tell our program that we will be putting aside some space. We will name that space A, and we will name another space B. We can have multiple declarations on one line as long as those declarations are of the same type. So here we declare three variables, variable A, B, and C, all of type int, and variables D, E, and F, all of type double. You'll note that the names of the variables are separated by commas, and each line ends with a semicolon. When we assign a value to a variable, we take the value on the right side of the equal sign of the assignment operator and place it into the named space. What is on the right side is then put into the left side. The R value goes into the left, the L value. Now, what is on the right side, the R value, is fully evaluated before it is placed. The result of that evaluation is put into the left value. So our variable value goes into the named space. That is, our variable value goes into the storage space. An example of assignment would be A equals B, A equals 5, meaning the value 5 is put into the named space A. B equals 1.5, the value 1.5 is put into the namespace B. You recall that in our early example we had declared A to be an int, and therefore we are putting an int into that space, and B was declared to be a double. We are therefore putting a double, that is a value with a decimal point, into that space B. We can declare and assign all in one line. We'll do that with the declaration, that is establishing the variable type, the variable name, and then our assignment with the assignment operator and the variable value. So we have the declaration and the assignment on one line. Putting on one line that declaration of a variable type, our name, that is putting aside storage space, and then establishing the variable value. We'll note that each one of these lines ends in a semicolon. They're executable lines of code. Examples of declare and assign on one line, we have an int A, assign the value 5, a double B, assign the value 1.5. We can have multiple declarations and assignment on one line, again, as long as each one of the variables is of the same type. That is, all of the variables on that line are of the same type. So we have an int A given a value of 1, B 2, and C 3. All three variables of type int declared and given an initial value in this one line. We have the double named space D is given a value of 1.5, E 2.3, and F 4.7. Again, all of those variables are of type double and are given values of type double. That is, they have a decimal value. A variable, remember, when we're talking about a variable, we have the storage space, the name, that is the left value, and then the right value, the specific value of that variable. The assignment operator leads our program to take that which is on the right side, the right value, after full evaluation, and then place it into the namespace, that is the left value. Evaluation, again, what is on the right side is evaluated and put into the left side. If we were to declare a variable h of type int and give it a value of 4.5, the value 9 would be placed into the space h. If we were to then declare that, or to write that h, the integer h, was now to be given a new value, 7 minus 3, the value 4 would be put into the space h. Variable types can be of type primitive, that is, they're indecomposable. They can't be broken down anymore. Or they can be of type class. We won't talk about classes at this point. Classes require that we create instances of those classes. So we'll talk about the primitive variable types. These primitive variable types are Boolean, char, byte, short, int, long, float, and double. A Boolean is either true or false. A character is a single character according to the Unicode, and we'll talk more about that in another lecture. We can have a byte, which is an integer, as is a short, an int, and a long. Floats and doubles hold floating point numbers. A Boolean is either true or false, uses 1 byte of memory, and doesn't really have a size range. It's either true or false. A character holds a single character under the Unicode. It uses 2 bytes of memory and will hold all the Unicode characters. A byte is an integer, that is a whole number, uses 1 byte of memory, and the size ranges from the number -128 to +127. A short, again, holds an integer, uses 2 bytes of space, and will hold a value from 32,768 negative to +32,767. An int will hold an integer, uses 4 bytes of memory, and will hold something, a number, from size 2,147,483,648 to, that's the negative, to positive 2,147,483,647. A long holds an integer, uses 8 bytes of memory, and you'll see that it holds a very large number, positive and negative, that's in the quadrillion range. A float, 4 bytes, will hold numbers that are -3.4 to +3.4, moving that decimal 38 points in either direction, with 6 to 7 significant digits. A double will hold, again, a floating point number. It will use 8 bytes of memory and will hold numbers from -1.7 to +1.7, moving those decimal points 308 positions, and this will hold 14 to 15 significant digits. So when we talk about variables, those values that we expect to change during the execution of our code, or that can change during the execution of our code, we must declare them, that is, announce that we will have them, and when we announce that we will have them, we must specify their type. We assign values to those variable spaces, and when we do, we must assign to those variables values that are of the correct type, that is, they will fit into that space. Variables can be primitive or class. Remember that primitives, we went through them, what they would hold, their names, and the range of numbers or values that they would hold. Thank you for listening.